Welcome to Math by Tree channel. In today's video, we are going to see how to find nature of a quadratic equation. So, quadratic equation comes to CBSE students in class 9 and 10. So, you know how to factorize using a formula method, factorization, and then splitting the middle term. Now, in today's class, we are going to see how to find nature of the quadratic equation using discriminant formula. Okay, so let's begin with the formula discriminant. So discriminant can be written as discriminant can be written as d. D is nothing but b square minus 4ac. This is our formula. Okay, so this discriminant have three cases. So each case have each value for the roots. Case 1. Discriminant, that is b square minus 4ac, is greater than 0. So when discriminant is greater than 0, then the roots are real and distinct. What is real roots? So real roots means in graph, usually our quadratic equation graphs are in the form of parabola. Okay, so d equal to b square minus 4ac value is greater than 0, then your graph look like this, somewhat like opening upwards or opening downwards. It depends on the values of coefficient of a. Okay, now if the value d value is greater than 0, then your answer will be roots will be real roots. Okay, so it's going to be a real and two different values, so it's called as distinct roots. Okay, so here one root and here one root, so it's going to be a two values for x, so it's called real and distinct roots. Now let's go for case 2. Case 2 is nothing but same formula, discriminant d equal to b square minus 4ac is equal to 0. When it will be equal to 0? When the parabola or the curve of the quadratic polynomial or quadratic equation just touches the x-axis. So it just touches the x-axis. It means it has roots are real and equal. Okay, so here you can't say this as this quadratic equation has one root, because one root means the graph should be a straight line like this. Then it is no more a quadratic equation, it's just a linear equation. So here the two roots are equal. Okay, for example, in some equation while solving, you will get answer for x as 2, 2, 3, 3, 4, 4. Like that you will get the same value two times. That is called the real and equal roots. So the graph will look like exactly like this. The curve might be here or downwards anywhere, but it will touch the x-axis exactly at one point. Okay, now we'll see for case 3. So case 3, discriminant equal to b square minus 4ac is less than 0. So it's going to be first case is greater than 0, second case is equal to 0, and third case is less than 0. When d will have less than 0, it has, when graph will look like, I am going to draw here, okay, like this. So it will never touch the x-axis. It will never touch the x-axis. Okay, so that is called less than 0, and it calls non-real roots. Okay, so this one is called as real and distinct roots. It has real roots with two different roots. Second case have real roots but equal roots. Both roots will be equal. And third case, it's going to be a less than 0. So the graph will look like somewhere the curves from this side or this side or this side, anywhere. Even it intersect y-axis, but it will never intersect x-axis. Okay, maybe you will get like this also, but you will never intersect the x-axis. Okay, so these are the three cases for the discriminant of the quadratic equation. So based on this, you can find the nature of roots, whether it is real or distinct, or real or equal, or non-real roots. Okay, so this is one of the most important chapter and one of the most important subtopic in class 10 and 9. So hope you got clear. With this data, you are going to solve the problems now. Okay, well, some quadratic equation and find nature of these quadratic equations. Okay, so we learned that d is greater than 0 for real and distinct roots, d equal to 0 for real and equal roots, d less than 0 for non-real roots. Let's solve each sum and find the nature of roots. Okay, so first one, here a equal to 1, b equal to -5 and c equal to 6. So our d is equal to b square minus 4ac. b square will be -5 the whole square minus 4 into a is 1 into 6 is c. Okay, so it's become 25 square minus, and 4 ones are 4. 4 into 6 is going to be 24. I'm sorry, here it's not square. Okay, so the answer is 1. So d is greater than 0. Therefore roots are real and distinct. Okay, now solve the second example now. So here a is equal to 1, b is equal to -6 and c is equal to 9. I am going to find d again, that is b square minus 4ac. Every time when you solve a problem, write the formula. Okay, so b square is minus 6 square minus 4 into 1 into 9. So this is going to be 36 minus 4 ones are 4, 4 nines are, it's going to be 36. So again it's 0. Therefore d equal to 0. Here roots are real and equal. And the final one, here a is equal to 1, b is equal to 2 and c is equal to 5. All are positive value, so our formula is d is equal to b square minus 4ac. So here b is 2 the whole square minus 4 into 1 into 5. So 2 square is 4 minus 4 ones are 4, 4 fives are 20. So our answer is -16 here, which is, I'm sorry, which is less than 0. Okay, so d is less than 0. Therefore roots are non-real. Okay, so this is what nature of roots works. So whenever you ask for to solve the problems, to solve the quadratic equation, first find the discriminant value. So this will help you to find the value easier, and also you can check the final answer after you get the value for x. Okay, so if you got d is greater than 0, then you can check whether you got the x value as both are real and distinct, and if your d is equal to 0, you can check both the roots are equal roots. If the d is less than 0, then you can check whether you got a non-real roots. Okay, and here is the small tip I like to give you. So non-real roots, many students confused that non-real roots is actually they are thinking root value. For example, root 3 equal to non-real roots. They are thinking that this value is non-real, but it is completely wrong. Okay, so this is actually a root 3 is equal to real roots. It's come under the real lines. Okay, so it is real roots. What is non-real then? What is non-real? Non-real means you have negative sign inside the root, so this will called as non-real. Okay, so non-real are negative sign inside the brackets are called as non-real. So if you have a negative value inside the root, then it can be written as negative, can be written as I, and it's 3. Okay, and here it's going to be I4. I am going to rewrite 2 come outside, and it's going to be I. Okay, and here it's going to be 5i, root of 5i. This I is nothing but root of negative number. Okay, some integer, and this I is called non-real. Okay, not just the numbers inside roots are called non-real, these are real actually. Only the negative numbers inside the root is called as non-real numbers. Okay, hope you find this video useful. Find this video useful. Kindly let me know if you have any doubts in comments, and if you like this video, please do like, share and subscribe to Mathvetri channel. Wait for next video. Until see you, bye bye, take care.